Hello everyone, welcome back to the another session in Principles of Programming Languages. We'll continue to learn about the 5th unit. The next topic of 5th unit is what? Functional Programming Language, which is ML. So basically people will get confused when I say about ML. ML doesn't stand for machine learning. No. The ML what I'm introducing from PPL is not machine learning. It is a meta language. We say it is a meta language. Now let's talk about ML. So one feature is a common feature among Lisp, Common Lisp, Schema and ML. All these 4 languages what we were discussed in the previous video and what we are going to talk in this video belongs to one category of languages. The category is what? Functional programming language. Lisp and the all dialects of Lisp. So that's what we were said in the last video. Basically Lisp is having some dialects of it, which is Lisp and Common Lisp and Schema. All these languages comes under one category. The category is what? Functional programming languages. And now I'm going to talk about the next programming language, which is ML. ML is also called as functional programming language, or else ML can also be listed under functional programming language. Now a question comes into our mind. Until and unless we don't have any differences in between these languages, we don't have these kind of languages, correct? For the same purpose we don't have Lisp, for the same purpose we don't have Schema. Definitely there will be some differentiations in between all the languages. Now that part will be even covering in this video. What are the differences and what are the uniqueness or what are the characteristics of ML? So it is also important question. My sincere advice to the students, don't skip 5th unit because you will see a direct question from the 5th unit. So one among it is ML. ML and Haskell, Lisp and Schema are direct questions I have to say. Now let's talk about ML. So ML is a language which is introduced by Milner and in the year of 1990, and it is a static scoped functional programming languages. So here one point you have to understand. We were discussed about static scoped imperative languages. Now this is what static scoped functional programming languages. Now the default type is what? Static typed, static scoped or static typed functional languages. The default type of ML is what? Integer. Fine. Now, so like Schema. Schema is also static scoped programming language. That's the reason if you remember the last video of Schema, there we wrote a function which is square root of x equal to x into x and we were passed a parameter, right? We did this one in the earlier video, that this is what a static scoped language. The scope of this parameter will get up to this boundary or up to the statement itself. So these languages are what? These are static scoped languages. What are static scoped languages? Lisp is a static scoped language and Schema, even ML is a static scoped language. And however, it differs from Lisp and its dialects including Schema in a number of significant ways. Though all these 3 languages are static scoped languages, we have some differences when you compare these languages with ML. Those differences are, it is a strongly typed language, the first difference. So this feature will not see in the Lisp and Schema. Though those are static scoped languages, those 2 languages which are Lisp and Schema are not strongly typed languages, whereas ML is strongly typed language, whereas Schema is essentially typeless. Fine. ML has type declarations for function parameters and the return types of functions, although because of its type inferencing they are often not used. So ML is what? Type inferencing function or else type inferencing feature. The type of every variable and expression can be statically determined. ML, like other functional programming languages, does not have variables. That's what we say ML and Haskell. The language what I'm going to teach in the next video is Haskell. ML and Haskell are having this thing, which are not having any variable. Will not define any kind of variable in ML and Haskell. We say these are what? Purely functional programming languages which doesn't have any kind of variable. So these are what? unlike imperative variables, these don't have any kind of variables inside. Now, here the uniqueness of ML when you compare with the other programming languages functional programming category, it maintains a table. Yes, it maintains a table. This table is called as evaluation environment table. So this purpose of this table is what? It stores the names of all implicit and explicit declared identifiers in a program along with their types. So evaluation environment, whatever parameters are involved into evaluation, either the parameters will define implicitly or the parameters will define explicitly. Those implicit and explicit variable declarations will be defined in evaluation environment table. This like a runtime symbol table, when an identifier is declared either implicitly or explicitly, it is placed in the evaluation environment table. Another important difference between schema and ML is that ML uses a syntax that it is more closely related to that of an imperative language than that of Lisp. That we'll see with an example. We'll let a factorial ka program with using pattern matching, without using pattern matching. When I say we don't have any pattern matching technique in ML, then we'll use control constructive statements, that we'll use if and else. When I say that we are using pattern matching, so whatever will repeat the pattern, whatever it repeats, that pattern will put into OR symbol. That part we'll see. Now, for example, arithmetic expressions are written in ML using infix notation. Fine. The same similarity we might have seen in schema and Lisp. If I wanted to calculate two numbers addition, let's say plus 5 and 7, we use this is what infix notation. We'll use a prefix notation in Lisp and schema. ML it takes infix notation. Infix is what? 5 plus 7. Infix. Prefix is what? Plus 5, 7. Function declarations in ML appear in the general form. This is what the function declarations in the ML. Fun is a keyword, function name, formal parameters equal to expression. So this is what the function declarations in ML language. Let's see, all the functions will get declared using a fun keyword. So here, fun's circumference or 3.14, some formula we wrote here. So now, this is what the type, that point we have to see here. Now we can discuss about type inference, and this feature we won't have in schema and Lisp. Type inference, whatever data type parameter we were giving as an actual parameter to the function, that parameter only we'll use here. So that what we can say, actual and formal parameter can be same and has to be same. This specifies a function named circumference that takes a floating point which is real in ML. So ML accepts two kind of data types, real and integer. Basically, it takes integer as a fundamental or default data type argument and produces a floating point result. The types are inferred from the type of the literal in the expression, likewise in the function. This argument and functional value and inferred to be of type integer. So the reason is what? When you do not find any kind of data type over here, we say it is a integer because it is a default data type. Now look at here. It has to be a default one, but having the feature of type inference, as the value of 3.14 is written in floating point, the value of this circumference of R will be written in floating point. That float is termed as real in ML language. So that's what type inference. Now you can see here also, so ML determines the type of both the parameter and the return value from the star operator in the function definition, because this is an arithmetic operator, and that's what we were seeing here, right? We said in the earlier slide that it takes infix notation. So this is what infix notation. In ML, the default numeric type is what? Integer. So having the feature of type inference, whatever value it returns, let's say if it returns a real value, So automatically, that's what strongly typed language, right? We were discussed strong typing in second units. What is strong typing? It will be bind the value to the variable, or else it will bind the value to the data type in the program itself. So basically, when you look at this x value, the default is what? Integer. If x value is, you said that it is of something like of 3.3. So according to the strongly typing feature, this has to be bind to the real data type. That's what the feature of strong typing, that's what the feature of type inference. So both the features were there in ML. Now, so here I have an example to show you, which is factorial of a number. This program will write using pattern matching and without using pattern matching. So without using pattern matching, we have to use if and else block. If and else block. In pattern matching, whatever pattern it repeats, that will put under logic OR symbol. Now let's see this code with pattern, without pattern matching. Function is the keyword, fact n of integer, it's a formal parameter, and the expression whatever it having. The expression is what? If n less than or equal to 1, then 1, else n into fact of n minus 1. Now look at the pattern matching. Whatever pattern is repeated, that pattern we put under logical OR. Now fact is equal to, fact of 1 is equal to 1. If it is not, fact n into int n is equal to fact of n minus 1. So this is what, how pattern matching will helpful in ML. Now, so this is what a simple summary to understand in single slide. ML is a static scoped and strongly typed functional programming language that uses a syntax that is more closely related to that of an imperative language than to Lisp. Why the reason we were talk about imperative is what? Basically imperative syntaxes will be written in fixed notation. Lisp will be taken prefix notation. So in that similarity, we just comparing the imperative versus functional programming languages. It includes a type inferencing system, exception handling, a variety of data structures and abstract data type. ML does not do any type corrections. The reason why we don't have any type of correction is what? We will be having type inference feature. When you have a language with type inference feature, whatever the value is expected from that expression, it will bind automatically. That's what type inference feature. Multiple definitions of functions can be defined using pattern matching of the actual parameter form. So this is what querying is a process, replacing a function that takes multiple parameters with one that takes a single parameter and returns a function that takes the other parameter. ML supports this concept. So this is about ML language. Thank you all.